Hey everybody, welcome back to the last unit. And when I say unit, I mean very small mini unit, because we only have a few classes left of the year. Yay! So here's the deal. Correlations, it's a big topic they like to talk about in college level stats classes. So I want to give you the greatest hits there is when it comes to correlations, so that when you get to a college level class, you kind of know what to expect and what's coming up. So let's get started. Say for instance, I'm doing a study, and in the study I'm gathering two pieces of information from people. I'm gathering how many hours of sleep they get on average, as well as their high school GPA. And you can see the data right up here. Now, what a correlation it's a mathematical, let's just say calculation to show that there is a connection between two variables or two things. And what's nice about it, it's a quantifiable number so that you can actually say, hey, this is how connected two things actually are. Now, a lot of times it gets messed up with one thing causes another. Like for instance, sleep somehow causes a certain effect to GPA. That's not what correlations are all about. You might have heard this argument between causation and correlation. Really, all a correlation is it just says that, hey, there's a connection here. It's not a perfect one, but there definitely seems to be one. Now, eventually what you'll learn how to do, either in this class or in subsequent statistics classes, is prove, using a hypothesis test, if a correlation indeed is significant enough to prove something, right? So for instance, let's take a look at this. It's a very basic study, and we'll see if there's a connection between sleep and GPA. Now, to be honest, these numbers are completely doctored, made up, so don't quote me on this. Don't go out and change your sleeping habits just yet. Anyway, so what we're going to do is we're going to start by doing all things, or the main first thing that you do when you are dealing with correlation data or two set or two variable data, is you're going to make what is known as a scatter plot. You guys have done this enough in school, you already know what these are. So as of now, let's just save us some time and only do these on Excel or on Google Sheets. Now, if you saw what I did insert chart. Google Sheets is smart enough to know that, hey, look at, he probably wants a scatter plot, which I do. You could have changed it if it does something different, but I've done this a couple times. It like auto knows that you want a scatter plot when you're doing two pieces of data like this. All right, so if you take a look at the scatter plot, you can already tell that there's already some kind of something going on, right? And the reason I say that is it seems that as I go up in hours of sleep, it seems that the dots kind of are slightly getting higher. So we would call this a positive correlation. The reason being is the lower numbers of sleep, aka the X numbers, when the X values are a little lower, the Y values are a little lower. And when you go higher on the X, the dots generally go up with that. So that is why I can see it's a positive correlation. Now, beyond that, Excel and Google Sheets does a really, really good job at analyzing this. So for instance, I can go ahead and sneak in here and click this, and I can go to edit chart. And if I, for instance, want to customize a little bit more of this, what I mean by that is I can go here, I can click on stuff like the axis title and all this other stuff, mess with the horizontal axis, like if I want it to start at a certain value or end at a certain value, I can do that. But what I'm going to do is I'm going to go to series, and I'm going to go to trend line. And the trend line, what it will do, let me just put the exit out of here, it will slap what is known as, you probably have heard this before, a best fit line. And a best fit line, what it is doing is it is trying to, the gaps between the dots and the line, it's trying to narrow down. Pretty much it's creating a line that is trying to reduce that distance, okay? Now, later on, you'll learn the fancy word for the distance between a dot and a line. It's called the residual. It's the vertical distance between a dot and the best fit line. So, for instance, for this data point, the residual is 0 because it's smack dab on the best fit line. But it's really, really easy on spreadsheets, obviously, to do these best fit lines. Now, say, for instance, you want the actual equation so that you can maybe make some predictions. For instance, let me go here. I'm going to go back to Edit Chart. I'm going to go back to where I was, Customize, go back to Series, and I'm going to go down. Instead of below trend line, there is a few labels, and this label says Use Equation, and that gives you a little bit more options. Now, in upper level stats classes, there's other types of trend lines. There's exponential trend lines, logarithmic. These are the ones that you'll see, like, for instance, on the news when they're talking about COVID-19 stuff. But most of the stuff that we're learning in this, and especially introductory stats classes, will always be linear. The other stuff, obviously, is a little bit more mathematically complicated. Now, what's nice about knowing the best fit line equation is, say, for instance, if you're looking at all the sleep data and you're like, you know what, my number's not really even on here, right? I get 12 hours of sleep because I've been sleeping in. I don't got anything else to do. Let's go ahead and see if we can calculate what the GPA might be for someone who sleeps 12 hours. So what you can do is you can take this equation and you can plug in 12 and for X and see what the best fit line predicts. So like anything, I would start an equation with an equal sign, and I'm going to go, what is that, 0.244 times 12, because I want to predict for 12 hours, right, plus 1.55, and then hit enter. Now this is going to say that I am going to be getting a 4.4 or 4.5 GPA. Now, clearly there's some limitations to these to this prediction, but that is a nice thing that knowing the best fit line equation can do. It can help with a prediction. Hopefully, if we have enough time, I can show you how to do what's known as a prediction interval, which is the same thing I just did, except it gives you a margin of error, kind of like what we were doing with confidence intervals. So you can have, like, here's my prediction plus or minus this amount kind of thing. So that's obviously possible as well in statistics. The other thing that you're going to want to be able to do with data, in a spreadsheet at least when you're doing correlations, is something called the correlation coefficient. The correlation coefficient is, like I was talking about earlier, it's that quantifiable number that kind of gives you an idea of how much of a connection two variables have between each other. Now, in order to do this in Sheets or in any spreadsheet program, you're going to go to equals. You're going to type in the command, which is CORREL, or Correl. You can see it says it delivers what's known as a Pearson product moment correlation coefficient. Fancy word for just correlation coefficient. What you're going to do for this, you got to do in this order, is you select your X variable or your independent variable, if you really want to get technical, first. You highlight it. You then hit a comma. You then highlight your Y variable, and then you close off your parentheses. Then you hit enter. Now the correlation coefficient is coming out as 0.781. Now, hopefully by the end of this lesson, you'll understand what that number means. There's a little bit more to it than just the number, but for now, we'll just keep it like that. So keep a connection between 0.781 and this chart or this picture. Let's go on to another example. So say, for example, I'm looking at GPA and hours playing video game. So like maybe one's GPA somehow affects the number of hours they're playing video games. Now, some of you might ask, like, well, which one's the X, which one's the Y? It really depends on which one you want to say is causing what or is affecting what, right? So I think that GPA somehow can predict hours of video game, or if you want, you can reverse it and see if there's a reverse correlation there. But anyway, we're going to go through the same step. So I'm going to highlight all my data. I'm going to go to insert. I'm going to go to chart. It's going to pop me down a scatter plot. And this scatter plot, you can see, is, for the most part, looks like it's trending down, but you'll notice that the dots are a little bit more spread apart. So let us get a trend line, or a best fit line is another way to say that. I'm going to go edit chart, customize. We're going to go to series. We're going to go to trend line. You can pick your different type of trend line. Again, keep it linear. And then we're going to even throw a little equation on there as well. We'll exit out of the chart editor and we'll move this out of the way. and you'll see that, yes, indeed, that this is definitely trending downwards over time. So it seems that pretty much the higher your GPA, the less amount of hours you are spending playing video games. Sorry for all you gamers out there. There is this outlier up there, as you can tell. This person has a 3.9. They play 12 hours. So it's not definitive, but there definitely seems to be a trend downward. So we'd say that this definitely has what is known as a negative correlation. Now, I'm going to calculate what is known as the correlation coefficient again. So I'm going to go Correl, parenthesis. I'm going to just click and drag down. There's my x's, comma, click and drag down. There's my y's, parenthesis, and you'll notice that my correlation coefficient is negative 0.55. Now, between these two examples, the first one, you got a positive 0.7, and the second one, you got a negative 0.55. The first thing you'll notice is that correlations can either be, or correlation coefficients at least, just like I've been talking about, can either be positive or negative. If, for instance, your best fit line has a negative slope or it's going downwards over time on the x-axis, then again, your correlation coefficient will show up as negative. If it is positive, you can go ahead and obviously see that you'll have a positive slope, positive line as x values increase. Another thing you'll notice between these two is you'll see 0.78. The dots are a little bit closer together, where negative 0.55, that number is just slightly smaller. You'll see the dots are actually further away. Now let me drive this home a little bit. Let's take a look at this data right now. And in this data, you'll see we have shoe size, we have GPA, and I'm trying to see if shoe size has any effect on GPA, if there's any correlation there. Now, I've already carefully done the correlation coefficient. You can see my formula up there, and it's returning negative 0.04. That number is very, very close to 0. So, any of you guys want to predict what a scatter plot might look like for this? Give you a second to do that. And as you're thinking about that, let me make this scatter plot. So I'm going to go to Insert Chart yet again, and if you take a look at it right now, if you look at the scatter plot, even though, yes, the trend line, let me just go ahead and put that in there. Even though, yes, the trend line is slightly negative, I'll just throw that in there. It is almost horizontal, meaning that there's some dots below, some dots above, and really there is no rhyme or reason. It doesn't look like there's a lot of connection between this, because of course shoe size probably doesn't predict GPA, or even vice versa. So what we've learned here is that the closer it is to 0, the less correlated it is, and the closer or the higher the number is, the better the correlation is. So I guess the question is well, how high can it get? So let me give you an example of this. Now this would be what I would call a very nice relationship, where you have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 for y. When I get the chart for this, I think you'll see where I'm going here. I'm trying to predict, or I'm trying to set up a perfect what is known as a perfect correlation, right? You can see that if there would be a line that would go perfectly through those. This is a blast from the Algebra 2 that you probably took last year. But I'm going to go ahead and get a best fit line, and when you see this, that yes, of course, the best fit line goes perfectly through this. Another thing is you'll notice is when I do the correlation coefficient for this, you will see that, it will return a solid 1. So what that is telling you is, because you can't get any more correlated than this scenario, that 1 is the max in terms of correlation. So the higher it is towards 1, the better the correlation. Closer it is towards 0, the less connection there is between two variables. And just to drive home the fact, if I were to reverse this, so 5, 4, 3, 2, 1, you'll notice that, again, perfect negative correlation, correlation coefficient is negative 1. So just to kind of give you one final, I guess, thing to think about, there's lots of pictures online about this stuff. So really there's a range between -1 and 1. Thing that's bothering me about this chart is -1 should probably be on the left and the positive should be on the right, but whatever. So you got your perfect negative correlation to high negative correlation to low negative correlation to no correlation to the flip side, right? And again, you should be thinking, when I see these kind of pictures, I'm kind of imagining it with its appropriate correlation coefficient, or vice versa, right? You should be able to kind of see that. So all in all, what I want you to be able to do is make a scatter plot on sheets, find the correlation coefficient, get a equation if you need it, maybe even if you want to use that equation to predict things like we did down here, and that's pretty much it. That's a quick little introduction to correlations, and we'll do some more stuff with it in the coming days before school's let out. All right. Well, you guys have a wonderful day. If you have any questions, office hours are between 1 to 2, Monday through Thursday, and if not, drop me an email. I'll talk to you later. Bye.